So here we have f of x is equal to the natural log of the square root of x. And we're trying to find the second derivative in this particular case. So as we have mentioned in previous videos, we can approach this problem in two ways. One way is we can apply the properties of logarithms to first simplify it. So let's see what that might look like. If the natural log of x to the 1/2 is the same as 1/2 of the natural log of x, then that makes our first derivative a little bit easier. So let's take the first derivative based on that, and we would get 1/2, constant multiple rule. The derivative of ln of x is 1 over x. So that gives us 1 over 2x, which, if we want, we can write as 2x to the negative 1. That'll make it a little bit easier for us to find the second derivative. Then the second derivative would be negative 1, that is, and we're going to reduce the exponent by 1, so it'll become negative 2. Leave the inside alone. Then times the derivative of the inside function, which is 2, and we end up with negative 2 over 2x quantity squared. If we multiply out the denominator, we will get negative 2 over 4x squared, which is negative 1/2, or negative 1 over 2 x squared. So let's look at our choices, and that definitely looks like option B there. Now we could have done this a different way, and that is just start doing the calculus immediately. And if we were to do that, we would have gotten f prime of x is equal to 1 over, the derivative of natural log of whatever is 1 over the whatever. So I'll leave that as x to the 1/2 instead of write it with a radical, times the derivative of x to the 1/2. And the derivative of x to the 1/2 is 1/2 times x to the negative 1/2. And that is 1 over square root of x times 1 over 2 square root of x. The square root of x's will become square root of x times square root of x is just x, so that leaves us with 1 over 2x, which is also 2x to the negative 1. So from there we would do the second derivative in the same way. So there's two different ways of approaching that problem. Either way is both ways are just as good as the other. Alright, that'll do it for this video.